In the not-too-distant past, warm weather was simply something to be endured. Warm indoor spaces were cooled by opening windows and hoping for a breeze to create enough air movement to have a cooling effect. As cities grew and population density increased, the concrete and brick used for buildings and for paving roads increased the amount of heat that was retained after sunset. Working conditions in the heat caused poor productivity. The need for a convenient, reliable system for cooling buildings became critical. Cooling is just like heating in many respects. Both of systems involve moving air over a source that changes the temperature of the air. In cooling, the air blows over a pipe carrying cold water or refrigerant gas. A refrigerant is a substance or mixture, usually a fluid used in a heat pump and refrigeration cycle. In most cycles, it undergoes phase transitions from a liquid to gas and back again. Many working fluids have been used for such purposes. Fluorocarbons, especially chlorofluorocarbons, became commonplace in the 20th century, but they are being phased out because of their ozone depletion effects. Other common refrigerants used in various applications are ammonia, sulfur dioxide, and non-halogenated hydrocarbons such as propane. In the refrigeration cycle process, there are 4 elements. Started from a compressor, the refrigerant gas is compressed into a hot, high-pressure gas. Right after the gas is getting hot, it goes to condenser where it will be cooled. As the refrigerant cools, it condenses into a liquid state. The liquid is cooled by surrounding the pipe containing the refrigerant with cold water or air. Afterwards, the warm, high-pressure liquid passes through the pipe to an expansion valve, which is also called a measuring device that allows the refrigerant to enter the evaporator at a controlled rate. The pressure is much lower than on the condenser. The refrigerant expands in volume as it passes through the expansion valve. In the end, the refrigerant evaporates and returns to a gaseous state. It's possible because refrigerant itself boils at very low temperature under the right pressure condition. At this point, the refrigerant is now able to absorb heat. The cold gas in the pipe absorbs the heat in the water or air. The refrigerant gets warmer and returns to the compressor as cold, low-pressure gas to be compressed again and repeat the circle.